All right, so we know how to do empirical formula. Empirical formula is when you find the simplest ratio of things.
You want someone to hold it for you?
No, because I'll be putting it on the stand in a second. The simplest ratio of elements. So Ridley, it's 9 to 8 to 4. Okay, that's the simplest ratio. We're doing this for elements, carbon, hydrogen, oxygen. Right, Jackson? So hydrate is the exact same thing, except instead of doing it for individual elements, we're doing it for compounds. So the process is exactly the same, but now it's for compounds instead of elements. When you think of hydrate, what do you think of?
Water.
Water, right. You got to hydrate. So crystals, this is actually much bigger than the real crystal. Crystals will sometimes get water trapped inside of it. The styrofoam balls represent the water. So water gets trapped inside. You can't see it, Garrison, because water is small. It's microscopic. But there's water trapped inside. So a hydrate has water trapped inside. Just out of curiosity, how would you get the water out? How would you remove it? How do you get water out of your hair?
Dry it.
Dry it with what?
Heat.
Heat, right? So when we did the lab, what did we do with the beakers after the stuff reacted? We heated them, right? We put them on the hot plates. We didn't weigh it immediately. We put them on the hot plates. Right, Ridley? So when we weigh our beakers, there's still going to be some water in there. No matter what you do, you can't get it all out because it's really hard. So my example problem is I want to find what is the ratio of water in the compound molybdenum sulfide. The big dot means that you've got a hydrate. So molybdenum sulfide dot question mark H2O. So how much water is there? For every one of these, how many waters are trapped inside the crystal? So it's basically an empirical formula, except instead of elements, we're doing compounds. So they have to give you some information. It's 86.7% molybdenum sulfide and 13.3% water. So if they give you percentages, Lily, just change it to grams. Okay? So percent, just go ahead and change it to grams. Then, when in doubt, convert to moles. So I'll do it for water first. What does 1 mole of water weigh? Well, we're going to have to add it up. Hydrogen is 1 times 2. Two plus 16 is 18. So that's the mass of 1 mole of water. We're gonna do the exact same thing for the molybdenum sulfide. But before I do that, are there any questions about what I did here? So find the molar mass, convert to moles. Do the same thing for the molybdenum sulfide. It is a weird name. Molybdenum is 96.0. I'm gonna go with 3 sig figs. I get that number off the periodic table. There's 2 of them. What's 200 minus 8? Thank you. See, we can still do math in our heads. Did you ever read the book Hitchhiker's Guide to the Galaxy? Some alien species was building an intergalactic highway, and they're gonna wipe out the planet Earth, but they decided not to because humans were the only species left that could do math in their heads.
Did you just
Sulfur, 32.1. How many sulfurs? 5. 5 times 3 is 15. Plus 10, 160. 160.5. But I have to go with 3 sig figs, so that would round to 161. And add them together. 353 grams. Then we put into our calculators. That I'm not going to do in my head. So that's the moles of aluminum sulfide, that's the moles of water. So again, the process is just the same as we did before. Calculate to moles, get the ratio, and then divide by the smallest one to get whole numbers. So this one is always going to be the smaller one. And when I divide, I get 1 to 3. So that's going to be my ratio then. So for every 1 molybdenum sulfide, there's going to be 3 waters trapped inside. Okay. So again, there's going to be a problem just like this on the test on Thursday. The process is just the same as empirical, except again, it's compounds. So what questions do you have
That's it?
for hydrates? That's it.
So what's the difference between hydrates then?
So the only difference is like when you do, like, instead of doing single elements, where you're like, this molybdenum, this sulfur, you know, here you got it together as a compound. Here you got it together as a compound.
So you just break it up.
So it's just you're doing it for compounds instead of individual elements.